in its normal range. Now, technically, when they say arc sine, I didn't say it here. If they had written sine inverse like this, the graph will stop at -1 and +1, the range that is. If they had written in lowercase arc sine, here's the only difference. If you're wondering why do we have two ways of writing it, if it's a lowercase arc, what that means is continuing on. And now remember how sine was a wave? You would continue on the wave going up like this, and it would just climb like a snake, going up and down forever. It would never stop. It would be that same wave. But if they write sine with the -1 symbol, that means it's still a function. And remember, a function has to pass the vertical line test. This wouldn't pass the vertical line test, so it would not be. This means inverse function is what it actually stands for. It would not be a function with that. So we actually cut off this. When you say sine inverse function, you cut off the graph and you keep it between -1 and 1, so it doesn't bust on the vertical line test, because that would no longer be a function. It would be called an inverse relation. Lowercase arc sine just means inverse relation. It doesn't have to pass the test. Again, cosine, the same thing. So they take this graph from here to here. If you think about it, you're like, why don't they just go the same values from positive pi over 2 to down to negative pi over 2? Well, because if you did that in cosine, you would start here, that's pi over 2. You would get there, and you come back, and again, you'd be failing this test. So they take it from they take the positive values rather than mixing with. They could do it from the negatives down here, but just to be simpler, we stick with the positive values. So we go from 0 to pi as our range. Here, this one was negative pi over 2 to positive pi over 2. Tangents. Tangent will continue on and on. That's why it's not these closed dots. Tangents has arrows. They continue on. If you remember what excuse me, I shouldn't be saying tangent. It should be to say inverse tangent. If you remember tangent, it looked like S curves. Again. Well, this is a sideways S curve, just one of them. And again, the values are staying between pi over 2 and negative pi over 2. So, sketch the graph of y equals arc tan, inverse tang of x over 2. So here it is. Well, you can type it in your calculator. You can see it this way. The only thing that changes is dividing it by 2. That's on the inside. So if you think about HIVO, inside's a horizontal. Dividing something normally makes it smaller since its inside is opposite, so doubling it actually makes it get taller. So, I'm sorry, not get taller, get wider. So it'll be stretched out wide. So before it reaches its maximum, it'll be double its x values than normal. Let me go back to the previous page so I can show you. Here, you see it how it's coming up here, and it's at the value of 1. On this one, at the same halfway point, it's at the value of 2. So it's just been stretched horizontally. It's been doubled that way. All right, that's what's happened here. And so you have this one. Again, I don't spend too much time on graphs because you can just type this in the calculator. It's simple, and I'm not as worried about you grasping how to do it by hand.